Okay, anybody who is still coming will just find this already started. We continue with logarithmic equations. We have two, sorry, change the color. We have two log base 9 of y plus 2 log base y. Equals y of 9 in this. Okay, and this is equal to 5. Now, when we have to solve equations like this, you can see that the bases of the logarithms are obviously not the same. So what you'll have to do is change the base of the logarithm. Okay, and like I said last time, the base that you change to doesn't actually matter. The answer you get will be exactly the same. So I'm going to change the second one, if that's what I want to do. You can change the first one, it doesn't actually matter. So rewriting this, I get 2 log base 9 of y. And then this one, when I change the base, the 2 will remain over here. And then the technique of changing the base of the logarithm, this is just log base 9. Okay, so I'm changing it to base 9 so that the bases of the logarithms are the same. And this is 9. And then I have log base 9 of y, and this is equal to 5. Okay, so I've changed the bases of the logarithms. Our laws only apply to logarithms that have the same base. So if I want to combine logarithms, the bases must be the same. So I simplify what I have in the numerator over here. This is equal to 1. So this is 2 log base 9 of y plus 2 times 1 over log base 9 of y, and then this is equal to 5. And then from here we want to get rid of our denominator. So to get rid of the denominator, I'll multiply it throughout. So I'll say multiply by the denominator, log base 9 of y. Okay, then the same thing here, log base 9 of y, and then log, it cannot fit there, it's log base 9 of y. Okay, so those two will obviously cancel out, and then here I have 2 log base 9 of y times log base 9 of y. So when you're multiplying log base 9 of y by itself, that becomes log base 9 of y squared. So I have 2 log base 9 of y being squared, and then plus 2, because this one over here cancelled, and then this is equal to 5 log base 9 of y. Okay, now I'm sure you can already see that this is now becoming a quadratic equation, and with quadratic equations we usually bring everything to one side and then we leave the rest, and then we have 0 on the other side. Okay, so I have 2, let me scroll up. So I have 2 log base 9 of y. This is squared. And then this 5, when I bring it to the other side, I have minus 5 log base 9 of y plus 2. This is equal to 0. Okay, so what I do now is I can substitute. If you cannot see that this is a quadratic equation, I will make a substitution to show that this is a quadratic equation. So I can say let x equal to log base 9 of y. So you do not use y because y is already in the equation. You can pick another letter, w, z, t, f, k, it doesn't matter. Okay. So when I substitute, that means everywhere I have log base 9 of y, I'm going to replace that with x. So I'll have 2x squared minus 5x plus 2 is equal to 0. Okay, so that's how the substitution works. And this is 2x squared. Please mute your mic. 2x squared minus 5x plus 2. This is equal to 0. Okay. All right. Then this quadratic equation, you can solve it by factorizing. So remember factorizing, I said there, what you need to do is find two numbers that when you multiply them, they give you a certain number. And when you add them, they give you another number. So to get the multiplying number, what you do is you take the coefficient of x squared and the constant, you multiply them. So that is 2 times 2. The answer is 4. So I'm looking for two numbers that when I multiply them, the answer is 4. And the addition comes from the coefficient of x. So every term in the quadratic equation has been used. So I want two numbers that when I multiply them, the answer is positive 4. And when I add them, the answer is minus 5. And those two numbers are minus 4 and minus 1. Okay, so just the technique we use for factorizing. You multiply the coefficient of x squared and the term that is constant, that means it doesn't have an x, you get your multiplying answer. And then the term in the middle that has only an x, that is what your sum is equal to. Then I said what you do is you open your brackets and you put a 0. This is just a shorter way of factorizing quadratic equations. So then you put your x over there, your x over there, and then what you do after that is you put these numbers in there. So you put minus 4 and then minus 1, and then the coefficient of the coefficient of x squared, you divide each of them by that term, like that. Okay, then you simplify. This is x minus 2. And then this one is just x minus half. This is equal to 0. But then we don't like fractions when we factorize. So what you do is you take this 2 and you put it over there. So this is just the technique of doing it in a shorter way. If you did it in high school in a different way, you will see that our answers are exactly the same if you've done it correctly. So this is x minus 2, and then I have 2x minus 1. This is equal to 0. Then if you were to multiply this out, let's just see. When I say x times 2x, I get 2x squared. X times minus 1, that is minus x. You know we can hear you, right? So please mute your mic. Over here, 2200766596. Please mute your mic. I think the next time I'll just remove you from the class. Thank you. Okay, so let us continue. So I was multiplying it out. I say the x times the 2x, that is 2x squared. The x minus the x times minus 1, that's minus x. And then minus 2 times 2x, that is minus 4x. So I have the minus x minus 4x, that will give me the 5x. And then when I multiply, so I've multiplied those, and then when I multiply those two, I get positive 2. So the way I factorized it is correct. Then solving quadratic equations, two brackets are multiplying. It means the first one is 0 or the second one is 0. So I have x minus 2. This is equal to 0, or 2x minus 1 is equal to 0. Okay, that is not going to fit there. Minus 1, this is equal to 0. Okay, so we solve for x. I get x is equal to 2, or x is equal to a half. But then remember, x is something that I introduced, so y is actually what I'm looking for. Then you have to remember what we set y to. So it is over here. So we said x is equal to log base 9 of y. So now what I'm going to do is like an unsubstitution. So instead of x, I put back log base y of 9. This is equal to 2, or log base 9 of y. This is equal to half. And then I solve this equation. Okay, so to solve this equation, very simple. You rewrite each of them in exponential form. So you have y to the power of 2 is equal to 9. Remember how we change from logarithmic to exponential equation. And then the second one, we have y is equal, not y, it looks like a y, but it's a 9. 9 to the power of half is equal to, sorry guys, I'm not writing this correctly. This is log base y of 9 is equal to a half. Okay, now it's fine. Okay, and then this one is y to the power of half is equal to 9. So it can be a little bit tricky, but the more you practice, the better you get at it. And here for the first one, if y squared is equal to 9, we know that y is equal to 3, or it's equal to minus 3. But then minus 3 is invalid because you cannot have a base of your logarithm that is negative. So even though y squared minus 3 squared is equal to 9, minus 3 is invalid. The reason it is invalid is because when I go back and substitute it over there, I will have log base negative 3 of 9. And your base
Babe,
of the logarithm, yes, yes,
wasn't our base 9 to the power y? If you go back at the up there,
the substitution I made, yes, oh goodness.
log 9.
Okay, sorry, that is right. I should change that. Okay, so 9, it's log base 9 of y, log base 9 of y. Okay, then here we'll have y is equal to 9 to the power of 2 if I rewrite this, or y is equal to 9 to the power of half. Okay, now it's fine. Then I have y is equal to 81, or y is equal to 3. Here, 9 to the power of half has only one solution because the square root of 9 is a positive number, which is equal to 3. So those are your two solutions. Thank you for that. Then the next one, this is C in your book, in the notes. So we have log base 3 of y minus 2 log base y of 3 plus 1. This is equal to 0. Now with this logarithmic equation, you can already tell that when I have different bases, like I do over there, when I change the base of one to the other, I always end up with a quadratic equation, and that is always the case. So here, what I'm going to do is, this time I'm going to change this one over here, just to show it doesn't actually matter which base you change. And the technique of changing the bases is you have your big fraction, then I put log of the new base, log of the new base in the denominator, then the argument in the numerator, then the base in the denominator, and everything else stays the same. And then you see that your logarithm has all the logarithms in the equation have a base of y. Now in the numerator here, log base y of y, that is equal to 1, because we said anything to the base of 1. Log of anything to that same base is equal to 1. So I have 1 over log base y of 3 minus 2 log base y of 3 plus 1. This is equal to 0. Then the same thing we always do, multiply the denominator out. So I have 1 minus 2. Then when I multiply this denominator over here, you will see that that logarithm becomes squared. So I have log base y of 3 squared, and then plus log base y of 3, and this is equal to 0. Okay, so this I got by multiplying this denominator with the 1. And when you multiply 1 by anything, the answer is that something you multiplied 1 by. Okay, so again, my substitution, say let k equal to log base y of 3. Then I have 1 minus 2k squared plus k is equal to 0. So I have log base y of 3. We said I'm going to equate that to y. So when I substitute that, I get minus 2k squared. And then over here, I have log base y of 3. It is k. So I put k, and that is where these two come from. Now with this quadratic equation, with the quadratic equation, what you want to do is write them in standard form. Usually you want your coefficient of k squared, whatever is being squared, you want that one to be positive. So you rewrite it. Okay, just a moment. Okay, so you rewrite it, you take everything to the other side, that way that one goes that way, and the one goes that way. The reason I'm doing that is I want the coefficient of k squared to be positive. Okay, so I have 2k squared when I take everything to the other side, and then minus k squared minus 1. This is equal to 0. Okay, then this equation, you'd factorize it the way that you normally do. Okay, somebody's mic is not muted. Right, so when I factorize this, I say I'm looking for two numbers that when I multiply them, the answer is 2 times negative 1. So it's this 2 over here and the negative 1 over there. Okay, so I take the coefficient of k squared and the constant term, and then I multiply them. The answer is negative 2. And then when I add the two numbers, it should be equal to the coefficient of k, which is equal to minus 1. So when I add them, what I should get is negative 1. So you're looking for two numbers, you multiply them, the answer is negative 2, and when you add them, the answer is negative 1. And the two numbers, okay, 2200486622. I muted your mic, you unmuted yourself. I removed you, you come back with an unmuted mic. Okay, if you continue this, I will block you from this channel completely. Okay, so please let us mute your mics so that everybody can hear what is happening. If you have a question, you unmute, you ask your question, and then you mute back, please. Right, so two numbers that when we multiply them, the answer is minus 2, and when we add them, the answer is minus 1. Those two numbers are negative 2 and positive 1. So I have negative 2 and positive 1. When I multiply these two, the answer is minus 2, and when I add them, the answer is minus 1. Then I factorize here. We said we open our brackets and equate this to 0. You put the coefficient, so the variable you were using. So here I was using k. Then I put the two numbers inside the brackets. It doesn't matter which one comes first. And then what you do is this coefficient of k squared, you divide each of those terms by it and simplify. So I have k minus 1, and then I have k plus half. That is a fraction in its simplest form. Then we don't like fractions when we are factorizing quadratic equations, so we bring this over there. All right, so I have k minus 1, and then this is 2k plus 1. Okay, this is equal to 0. And then you can try multiplying it out and see if what you get is equal to what you started with. So the k times the 2k, I get the 2k squared, and then k times 1 is positive k, minus 1 times 2k, I get minus k, and when I add those two, the two terms in the middle, and then these two multiplied gives me negative 1. So that is what I have over here. So that is fine. When I go and solve for k, I have two brackets multiplying and the answer is 0. Then that means the first one, k minus 1, k minus 1 is equal to 0. K minus 1 is equal to 0, or 2k plus 1 is equal to 0. Now this is true only when your answer or your product is equal to 0. If I had any other number over there, I cannot do what I have just done over there. So if it was 2, for example, I cannot say k minus 1 is equal to 2 or 2k plus 1 is equal to 2. Because if two numbers are multiplying and the answer is equal to 2, it doesn't mean that one of them must be 2. It is possible to find two numbers different from 2, and their product is 2. But with 0, if two numbers are multiplying and the answer is 0, it means one of them must be 0. It's a must. Okay? Then I have k is equal to 1 or k is equal to minus a half. Now I have to scroll up and see what I said k is. K is over here. So this is log base y of 3. Okay, so I have log base y of 3. This is equal to 1 or log base y of 3. This is equal to minus a half. Then what you do is you write each of them in exponential form and then you solve. So the first one, you have y to the power of 1. This is equal to 3. This just means y is equal to 3. And for the second one, you have y to the power of a half is equal to the power of minus a half. So this is minus. Okay, it's minus a half, and then this is equal to 3. So what you can do, you want to get rid of this minus a half. What you can do is raise both sides to the power of minus 2. So I have y to the power of minus a half. This is to the power of minus 2, 3 to the power of minus 2. The reason I raise it to a power of minus 2 is because I know half and minus 2 will multiply, and if they are both negative, my final answer will be y to the power of y to the power of 1, which is what I want. And then 3 to the power of minus 2, this is 1 over 3 to the power of 2. Remember your laws of indices, and this is equal to 1 over 9. So your two solutions, y is equal to 3 and y is equal to 1 over 9. Excuse me. And then you'll see that both of these solutions are valid. You must always check, substitute them back, and then check if what they're not giving you a math error. So this 3 and 1 over 9, both of those can be an argument and a base. So they are both valid. And D, log, sorry, this is 9 log base y of 2. This is equal to log base 2 of y. Okay, so this one will do it in pretty much the same way. The bases of the logarithms are not the same. The base of this logarithm is y. The base of that one is 2, so I'll need to change the base of the logarithm of one of them to the other. So I'm going to change the first one. So I write the 9, then we said one big fraction, then I'm going to change it to base 2. So this becomes log base 2. Then I put log base 2. So this is a technique. It's what you have to do. Then the argument goes to the numerator, and then the base goes to the denominator, and this is just equal to log base 2 of y. Then the numerator over here, log base 2 of 2, this is just equal to 1. So I have 9 times 1 divided by log base 2 of y, and this is equal to log base 2 of y. Okay, then from here we get rid of our denominator. That means you multiply by this denominator on both sides. So I have 9. This is equal to, somebody's requesting control. I don't know what that means. If you have a question, you can just unmute your mic and then ask your question. Does somebody have a question? No, are we fine? Okay. Right. Then I multiply that on both sides. So I have 9 is equal to log base 2 of y squared. Okay, so with this one, you can let log base 2 of y equal to x, for example, but this one is very simple to solve, in that I just take the positive and negative square root on both sides. So if I let x equal to log base 2 of y, you will see that I have 9 is equal to x squared. Okay, now if 9 is equal to x squared, I substitute this over there. So instead of 9, I have, instead of log base 2 of y, I have x squared. And then this means that x is equal to plus or minus 3. Now when you get your solutions, it's always important to go back and substitute and see if what you have is correct. Okay, so I do this, log base 2 of y, so this is my x. The first one is equal to 3, and then the second one, log base 2 of y is equal to minus 3. Okay, so for the first one, if log base 2 of y is equal to 3, this means that y is equal to 2 to the power of 3, and this means that y is equal to 8. And then for the second one, write it in exponential form. 2 to the power of minus 3 is equal to y. That means y is equal to 2 to the power of minus 3, and this is just equal to 1 over 8. So it's 1 over 2 to the power of 3, which is equal to 1 over 8. So my two solutions, I have 8 and I have 1 over 8. Then the last one we have over there, this is log of a is equal to log base a of 1000 a squared. Okay, so again, here my bases are not the same. The first logarithm has a base of 10. Remember, when a base is not written, that means it is the common logarithm. So the base over there is 10, and over here the base is a. So what you can do is change the base of the logarithm of one of them to the other, and then you will see that you end up with a quadratic equation. So I'm going to change the one on the right hand side to have a base of 10. So on the left hand side I have log of a. This, remember, it's just one big fraction. Then I change the base 10. When the base is 10, I don't even need to write it. Log base of 10. And then the argument goes to the numerator. So this is the 1000 a squared. The entire thing, that is your argument. So it's not just the 1000 or the a squared, it's 1000 a squared. That is your entire argument. So all of it should go to the numerator. And then in the denominator, I have log base a. Then, sorry, log a. Then what you do as usual, this denominator, we don't want any denominators, so you multiply or you cross multiply here, and then you will have log of a squared, because when I multiply log a with log a, I get log a squared. Anything you multiply by itself becomes that thing squared. And this is equal to log of 1,000 a squared. Okay. Then with this one, what you need to do is, you may be thinking, yes, I need to substitute this log a, but if you look on the right hand side, you don't have a log a, you have log of 1,000 a squared. So this log 1,000 a squared, you need to split it up and use your laws of exponents. You have 1,000 times a squared, that is a product. So when you split it, the product becomes a sum. So this will be log a squared. This is equal to log of 1,000 plus log of a squared. Okay, and then over here, my argument has an exponent, so the exponent can come down. So this is again log of a squared. Now 1,000, I can also write it as 10 to the power of 3. So this is log 10 to the power of 3 plus 2 log a, like that. Okay, then my 10, which is the argument, has an exponent. Then the exponent can also just come down. So again, this is log a squared, and this is equal to 3 log 10 plus 2 log a. Now log 10 over here, this is log of 10 to the base of 10. And we said anything that you take log of to that same base, that is just equal to 1. So what I have is just log a squared is equal to 3 times 1, which is just 3, plus 2 log a. So now you see clearly I have a quadratic equation, and with my quadratic equation I always bring everything to one side. Then this is log a squared minus 2 log a minus 3 is equal to 0. So I have brought everything to the same side. Try and write that 0 better. Okay, so I have brought everything to one side. Now I make the substitution. I can say let t equal to log of a. Okay, again, remember log a just means log base 10 of a. So this is t squared minus 2t minus 3, and then this is equal to 0. And then the quadratic equation, usually with these quadratic equations, with logarithms, because we haven't done the other techniques, but I'm sure you did the formula in high school, we haven't done completing the square. Most of the time the questions you get, you will be able to factorize it. So again, to factorize this, you look for two numbers that when you multiply them, the answer is equal to the coefficient of t squared, which is 1, times the constant. So I have 1 times minus 3. This is just equal to minus 3. And when I add the two numbers together, it should give me the coefficient of t, which is minus 2. So I'm looking for two numbers. When I multiply them, the answer is negative 3. And when I add them, the answer is negative 2. The two numbers are negative 3 and positive 1. So then I factorize my equation like that. So I open my brackets. Remember, this is also just the technique. there's a more formal way of doing this, and when we get to quadratic equations in our next chapter, we will do that. So what I do is I put the variable, this is t and this is t, then these two numbers, I put them in the bracket. So I have -3 and then I have +1. And again, it doesn't matter in what order you put them, whether you put -1 there and then -3 over there. It will not change your value of a. Then we would normally divide by the coefficient of t squared, but in this case the coefficient of t squared is 1. So dividing by 1 doesn't change anything. Then you say the first bracket, t minus 3 is equal to 0, and then t plus 1 is equal to 0. So if t minus 3 is equal to 0, this means that t is equal to 3, and if t plus 1 is equal to 0, this means that t is equal to -1. Then remember, t is not what we were asked to solve. We're asked to find out what a is. And go back to my substitution. I said that t is equal to log of a. So what I actually have here is log of a is equal to 3 and log of a is equal to -1. So I have log of a is this looks like a base, but it's not. Log of a is equal to 3, or log of a is equal to -1. Now this one here, if log of a is equal to 3, when I write this in exponential form, remember the base is an invisible 10 over there. This means that a is equal to 10 to the power of 3, which means that a is equal to 1,000. Like that. Try and put that in. So this is 1,000. Okay. And on the other hand, if log of a is equal to -1, remember again, there's an invisible base 10 there. This means that a is equal to 10 to the power of -1. So a is just equal to 1 over 10. Okay, so that is all the questions in your notes. Now the questions like this, the technique is always going to be the same. What you need to do is change the base of one of the logarithms to the other, and then from there you will come up with a quadratic equation. The quadratic equation, you will be able to factorize it. Okay, so you factorize it and then you solve. Okay, do we have any questions on that? Okay, if there are no questions, then I have some more logarithmic equations, not necessarily like this one, but just for us to practice. So the first one, this is log base 5 for x plus 11. This is equal to 2. Okay, so to solve this one, what you do is just rewrite it in exponential form. So in exponential form, base to the power of the exponent is equal to the argument. So I have 4x plus 11. This is equal to 5 to the power of 2. Now we know that 5 to the power of 2, this is equal to 25. So I have 4x plus 11. This is equal to 25. Now you know how to solve this simple linear equation. Everything except x to one side, everything with x on the other side, and then you solve for x. So this becomes 4x, then I have 25 minus 11, so this is 4x, this is equal to 14. Okay, 25 minus 11, that is 14. Then what I do is I divide by 4 on both sides. Divide by 4, divide by 4. This means that x, if I write this in the simplest form, this is 7 over 2. Now, if this is a question on e-learning, please remember that it is now necessary to write this as a decimal. And the number of decimals you use must be the ones specified in the question. So if it says 3 decimal places, this is what you should write, 3.00. So we're trying to test, are you able to write any number to a given, yeah? Are we fine? Okay, so this is how you'd write it to 3 decimal places, even if it's just 3.0. So questions are not there just to test, do you know that the answer is 3.5? It's also testing you on other things, like writing it correct to 3 decimal places or 3 significant figures and all those things. Okay, then another one, we have log base 2 of x plus 5 minus log base 2 of 2x minus 1, and this is equal to 5. Now with this one, the bases are the same. When the bases are the same, all we need to do is use our laws and then combine the two logarithms. So here I'm subtracting. When I'm subtracting logarithms that have the same base, all I need to do is divide the arguments. So this will just become log base 2 of x plus 5 over 2x minus 1, and this is equal to 5. Okay, then you rewrite this in exponential form. So you'll have x plus 5 over 2x minus 1, and this is equal to 2 to the power of 5. Now 2 to the power of 5 is 32, so I have x plus 5 over 2x minus 1, and this is equal to 32. Then what you do is you cross multiply. You have x plus 5. This is equal to 32, 2x minus 1. This is x plus 5. This becomes 32 times 2x, that is 64x. And then 32 times minus 1, that is just minus 32. Okay, then again, everything with x on one side, everything without x on the other side. And then you will have 64x minus x. So I'm bringing this x to that side. And this is equal to 5 plus 32. Okay, 64x minus x. I'm just counting how many x's I have. So that is 63x. And then I have 32 plus 5. This is 38. Okay, then x is equal to 38 over 63. Okay, that is how you would do that one.
It's not 38 but 37.
Yes. Thank you. So that's your final answer. Like that. And then we can do one more. We have log base 8 of x plus log base 8 of x plus 6, and this is equal to log base 8 of 5x plus 12. Okay, so on the left hand side, the bases of the logarithms are the same, and I can combine them using the laws of exponents. So to combine them, what I do is just multiply the arguments. So I have log, the base remains the same, and then I multiply the arguments. Okay, this is plus 12. I just don't have space. Like that. Okay, so here when you have two logarithms, one on each side of your equation, and their bases are the same. So here the base is 8, over there the base is also equal to 8. You can actually solve this by comparison in the same way that we did with exponents. So the bases of the logarithms are the same and they're equal. It means that the arguments are also the same. So I have x plus 6. This is equal to 5x minus 12. Okay, so the bases of the logarithms are the same and it's equal. The coefficients of both of them is 1, so then I can equate them. If I had any coefficient, let's say this side, or a coefficient, yes?
Is it not plus 12?
Plus 12. My writing is too small. I cannot see it. Yes, it is plus 12. Okay, so I'm comparing the two logarithms. What I have on one side is equal to the other side. I do this only when the bases are the same. We did a previous question with two logarithms on either side. The bases were not the same, and that is why I could not rewrite it like that. Then what you do, you multiply out. You have x squared plus 6x. This is 5x plus 12. Now this one is a quadratic equation, so you'll have to bring everything to one side and have 0 on the other side. You have x squared, and then I'll just write it. This is 6x minus 5x minus 5x minus 12, and this is equal to 0. So this is just x squared plus x minus 12, and this is equal to 0. So this is a quadratic equation. You can factorize this. You look for two numbers that when you multiply them, the answer is negative 12. And this negative 12, I got it by multiplying the coefficient of x, which is 1, and the constant term. So I have 1 times negative 12, that is negative 12. And when I add them, this should be equal to 1. And that 1, I get it from the coefficient of x. So those two numbers are 4 and negative 3. So it's 4 and negative 3. So to factorize, as usual, I open my brackets, equate this to 0 because I have 0 on the other side, and then I put my variable, which is x, and then the two numbers that I got over there. So the first one is plus 4, the second one is minus 3. And again, it doesn't matter whether I write x minus 3 and then x plus 4. It's exactly the same. Then I have two brackets multiplying, and the answer is 0. I do the next step only when it is equal to 0. If I have anything else except 0, I cannot do what I'm about to do, which is this. So I say x plus 4 is equal to 0, or x minus 3 is equal to 0. So let's say I have 10 over here. I cannot do this where I write x plus 4 is equal to 10 or x minus 3 is equal to 10. That is not true. Okay? But with 0, it is always the case that when you're multiplying two terms and the answer is 0, it means the first one is 0 or the second one is 0. And from the first one, I'll get x is equal to minus 4. And then the second one, x is equal to 3. And you have to remember, no, I didn't make any substitutions, so those are just my answers. Now what you need to do is check if what you have will be valid or not. Now to do that, you will have to substitute the -4 and the 3. You substitute them back into the equation. So I got -4, let me just hold up. I got -4 and +3. If I substitute -4 over here, my argument is negative, so -4 is not a solution. So -4 I will say is invalid, but then I see when I substitute 3, I don't have any problems. So what I need to come and say is x is equal to -4. This one is invalid. So the only solution is x is equal to 3. So it's always important to check if your solutions are valid or not. Okay, so we will stop there for today, and we're done with logarithms. Tomorrow, I don't know, I didn't want us to start with the next chapter yet. So what we can do is between today and just the rest of the day, just email me questions on logarithms. If I don't get any questions, then we will just proceed with the next chapter. Okay, so email me questions. I'll look at them before 5 o'clock. Anything I get after 5 o'clock, I will not have time to sort out. So send it to me if you have questions before 5 o'clock, and then we will go over those questions in the next class. If I do not get any questions, it means you guys are all fine, and then we can proceed to the next chapter. Okay, so do we have any questions now? Okay, if not, I will see you guys tomorrow. Have a good day.